So this is the statement of the fundamental theorem of calculus. It says that the integral from a to b of some function large f of x by dx is equal to the function small f at b minus small f at a. So before we go into the diagram here, we'll talk through this example. So let large f of x equal 2x. Then if we were to find the area under this function large f of x between 1 and 3, then we would integrate from 1 to 3 over large f of x by dx. So that would equal the integral from 1 to 3 of 2x by dx. So when we have to integrate 2x, we get x squared. So this is the value x squared from 3 to 1. And that is equal to 9 minus 1, which is 8. So the area under this function y equals 2x from 1 to 3 is 8. So this figure is a copy from the graphical calculator that we've seen in the last video. So we have our original function here, f of x, which in this case is 2x. So that's large f of x. And when we integrate this function, we get this other function y equals x squared. So this is our small f of x. And we've seen that we calculated the area under this function large f of x from a point A to a point B. In the example here we did it was from 1 to 3. And we've seen that the area there is a value of 8. But we know that the area here is given by the value of the integrated function at point B, which is our f of b, minus the value of our integrated function at a, which is f of a. So f of b minus f of a, in this instance here it's 9 minus 1, so this height here is 9, and this height here is 1, so 9 minus 1 is 8. So this function here, large f of x, tells you about the gradient of the function small f of x. And the difference in the values of the function small f of x tells you about the area of the function large f of x. So the fundamental theorem of calculus relates gradients and areas.